Hi everyone, Queeveen here from the comfort of my kitchen. In today's video, we are going to take a closer look at the planets Neptune and Uranus. We have taken a look at both planets in their own separate videos previously on this YouTube channel, so if you want to take a look back at the videos dedicated to Neptune and the video dedicated to Uranus, they are out there, although they are a few years back now. Unfortunately, it's unlikely that much information has gone out of date. So we're pushing through towards morning here. We may come a little bit further back in the month just to keep things dark. We want to have Saturn above the horizon because Neptune is just next to Saturn. So if Saturn is above the horizon, Neptune is as well. I also want to get the Pleiades above the horizon, which are difficult to spot from the city, but I know that they're out here somewhere. So we'll very quickly bring up the constellations. Yeah, there we go. So there's the Pleiades. As you can see, difficult to spot. It seems to be one faint star rather than the collection we'd expect. But I know that Uranus is around there somewhere. We'll come back just a little bit earlier. So here we are about 3:30 in the morning on the 10th. So, of course, looking into the past here, it wouldn't be too different on other dates. Here we can see Uranus once we start zooming in a little bit closer. So this is a nice sort of tableau. This is a nice image with the Pleiades, the Seven Sisters, Venus there, and Uranus. If we move through a couple of days, we can see Venus and Uranus and the Pleiades getting even closer together there as they were a little bit earlier in the month. They're now moving further and further apart as we push into the future. If we zoom in and take a closer look specifically at Uranus, we can see Uranus there is magnitude 5.8 reduced to 6.62. Around magnitude 6 or 7 is the limit of human vision. In a perfectly dark sky, technically you should be able to spot Uranus with the naked eye, but recognizing it as a planet, seeing it as something different to the background stars, that's very difficult. And due to Uranus's very, very long orbital period, its very long year, we can see down here, 84 years roughly is how long it takes Uranus to get around the sun. So it does take a long time for Uranus to move relative to the background stars, which makes it harder to recognize as a planet. Taking a closer look here, we're looking pretty much at one of the poles of Uranus. Not sure if it's the North Pole or the South Pole, because of course it's not pointing really north or south, it's almost pointing directly at the Earth. We can see the rings of Uranus there from above, which is a great way to see them. They are very thin rings, very, very difficult to see. You wouldn't expect to see any of the rings through a telescope, certainly not a normal telescope that you may be able to afford as an individual. Much larger telescopes, research telescopes, can see Uranus's rings, and of course the Hubble Space Telescope and other space telescopes. Uranus has been visited. I don't know if it's listed at the side. I don't think it is. Uranus was visited briefly back in the 80s by the Voyager 2 probe. Voyager 2 was on its way out of our solar system. It swung past Uranus in the, I think, mid-80s, and then around Neptune later in the 80s, a few years later, the same mission, Voyager 2. We have had a flyby of Uranus, which discovered some of the moons, saw the rings. Now that we have space telescopes, we can look at Uranus from the Earth in some amount of detail, but it's still not quite the same as actually going there and taking a closer look. Uranus and Neptune have had far fewer visitors than Saturn and Jupiter. Jupiter has had multiple probes visited, Saturn has had a couple of probes visited, and even one, the Huygens probe, landed on Titan, landed on one of Saturn's moons. We don't have the same amount of information when it comes to Uranus and Neptune. For example, Neptune here, much, much further out again. We can see it there at magnitude 8, past the possibility of being visible to the naked eye, and its year down here at 164 Earth years. It takes an incredible long time for Neptune to get around the sun, so of course its motion against the background stars is even harder to detect. Triton here is a moon with an atmosphere, a very, very thin hazy atmosphere, not as thick and as obscuring as the atmosphere that we see on Titan, but it does have an atmosphere, and moons with an atmosphere are rare. We've found 2 of them in our solar system out of the hundreds and hundreds of moons that our solar system has. Saturn alone has about 200 moons. There are only 2 that are big enough to retain an atmosphere, Triton and Titan. So if there was any other moon in the solar system we might want to land on, it should be Triton. It should be one of the most interesting moons. But Neptune being so far from the sun, it is that little bit harder to get there and study it. Any probe sent to Neptune would take much longer to arrive. We can see Neptune's very faint ring there, again, only visible through very large telescopes, and Neptune's moons also only visible through large telescopes, even though Triton is quite bright and reflective. If we take a look at Neptune here, and we'll go right up to a massive telescope. There's no point in using anything small here, even a large telescope. Here we go. The biggest telescope that Stellarium simulates, yep, a Meade LX200, 16 inches aperture. We've got all of these lenses to help us, there we go, lowering our field of view but increasing the amount of magnification we're getting with what's left, and we're just about seeing Neptune and Triton there as separate things, and this is a massive, massive telescope. Anything a bit closer to a normal, more affordable telescope without these extra lenses to help, and even there with an 8-inch aperture telescope, you might spot Triton. It is a different colour. We move through a couple of days, you can just about see it moving around Neptune there, but that's incredibly difficult to pull off. It's incredibly hard to see Triton even with large telescopes. Even though we can now study Neptune and Uranus through things like the Hubble Space Telescope, the best information that we have about both of those planets is still from a flyby in the 1980s. We're going to get rid of the light pollution, which should label Uranus. Yep, so we've got Uranus labeled there. Neptune still not labeled because Stellarium knows that it's definitely not visible to the naked eye. Stellarium does register Uranus as being visible to the naked eye, even though I don't think I can see it. We know most of what we know about both of these planets from close-ups that the Voyager 2 probe took back in the 1980s. And by, oh, here we go. Albedo is written down here at the bottom. I wasn't seeing albedo for the moons in the last video, but I am seeing the albedo here, the reflectiveness, how much light is getting bounced back by the surface. The Voyager 2 probe in the 1980s took a closer look at Uranus and Neptune. That's where we get our recognition of their colours. Looking at these planets through a telescope, through most normal telescopes, they might look a little bluish, a little bluish like this, but the richer blue colour, the details, these clouds, we can see that Neptune there is a pretty blue, greeny blue colour, but when we take a look at Uranus, it should look a little bit paler. In reality, they're almost equally pale, and that's something that we did figure out recently using the data taken from the Voyager 2 probe in the 1980s. So we can see there, yeah, Uranus with more of that kind of greeny, almost more sickly colour, not quite as blue, not quite as cerulean as the way people imagine Neptune to be. But it turns out that that imagination, that presentation, it was just because of how the images were analysed. The images that were taken by Voyager had to be analysed, they had to be boosted. There we go, managed to click on Neptune even though it's invisible. They had to be turned into something we could actually see. The Voyager 2 probe had to compress its images down into a data stream and then send it back to the Earth. It had to be sort of rebuilt, recompiled, turned back into an image. We now know by taking a closer analysis of those images that Neptune and Uranus are in fact almost the same colour, but we mostly know that still from looking at information from that probe in the 1980s. Even though the Hubble Space Telescope can look at Uranus and can look at Neptune and can take a closer look, that's not really what the Hubble Space Telescope was built for, and it's not what gets given priority from the Hubble Space Telescope. The Hubble Space Telescope is very often used to try and discover new things, and looking at these planets from the Earth, it's hard to discover new things simply because they're so far away and it's so hard to see detail. So hopefully we will get a new mission to Uranus and Neptune in the near future. There has been some discussion recently about a mission specifically to look at the ice giants, which are so different. Here I'm not seeing albedo, so it's interesting what gets listed for what different things. But we don't know as much about the ice giants as we do about the gas giants, about Saturn and Jupiter. And as we discover more planets in other solar systems, understanding how these different kinds of planets work is useful. It gives us a better idea of how they form and what they can tell us about the conditions of the solar system, not just our own solar system, but other solar systems as they form. If we can get a better idea of the real composition of Uranus and Neptune, a better idea of the moons around these planets, their compositions, it'll give us a fuller picture of how things in our solar system are composed, which in turn gives us a better picture as to how our solar system was composed when it was still forming. So just a little bit about Uranus and Neptune, because we don't know as much about them, because they're these kind of distant edge of the solar system objects that we're aware of but that we don't really see, and that we don't really see in research as often, because it is Saturn and Jupiter and those nearby gas giants that get the bulk of the missions. And it is easier and cheaper to send those missions, but we're, getting to a point of diminishing returns. Obviously, we want to learn more about Saturn and Jupiter, but we will get more new information, more novel information quicker by sending it to Uranus and Neptune, because there's so much less that we know. We'll find out new things without having to try as hard if we can just get there and take a slightly closer look. So I hope you did enjoy this video, this exploration of Uranus and Neptune. If you did enjoy this video, please do like it. If you enjoy this kind of content, then you can subscribe to this YouTube channel in order to see more. You can also check out my website, queevinscontent.ie, where you can read some of this information, and hopefully I'll see you back here next time.